Okay. Okay, well, I'll just start recording here. Next examples will be good. So this would be on top, 3 minus y over y. Then we're dividing by 9 minus y over y. And now do you see how you have one fraction divided by one fraction? So now it is okay to say dividing fractions is easy as pi, flip the second fraction and multiply. So that would put y on top and 9 minus y on bottom. So now what ends up happening? You don't need a common denominator, right? Divide out common factors, right, everybody? So my answer is 3 minus y over 9 minus y. And I would accept that answer, or if you were an extra special student, what you would probably do is then say, that's negative y plus 3 in standard form, negative y plus 9, which factors out a negative 1, giving us y minus 3, factors out a negative 1, giving us y minus 9. These are mathematically equivalent, so I would accept either answer. Okay, next example. They're going to get harder and harder, so stick with me here. A couple more examples. Okay, I'm going to do number 10. Yes, we're not doing evens. I want to do number 10 if you want to write down so that you know that that's the one I'm doing, okay? So once again, it's all about keeping your work straight and being so very careful. So the first thing I'm going to do is just focus on the top. So we have a over parentheses a plus 1 minus 1 over 1. So get a common denominator, right? So we times by a plus 1 over a plus 1. You guys have got to be so careful. Like one error right here could just ruin the whole thing. So don't we now combine the top? So we have a, then we have to distribute our negative through. So won't that become minus a minus 1 on top, right? So in our numerator, we're going to have negative 1. And that was all over the common denominator of a plus 1. Do you agree? Okay, I'm going to put a box. That was my top. Let's do now the bottom right here. So we have a plus 3 over a minus 2 over 1. So now we're going to get a common denominator. So times by a times by a. The numerator is what we're focusing on. So we have a plus 3 minus 2a. What does that become? On top. Negative a plus 3, and that was all over a. Okay, so now I would once again rewrite the whole thing. So really we had negative 1 over a plus 1 divided by negative a plus 3 over a. So dividing fractions is easy as pi, flip the second fraction, multiply. So then we have negative a plus 3, right? So now you're going to factor, 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 factor. Well, that does factor. So we actually have this, negative 1 over a plus 1 times by a over negative 1 times a minus 3. So then divide out exact factors. The negative 1s divide out, if that's it. So on top was an a, on bottom an a plus 1 and an a minus 3. Questions on how to do that? So yes? On complex fractions, this will be the section of the test where it's not necessary. Great question. Okay, let's do another one, but they're just going to keep getting a little bit harder and harder. So you guys can see it's not anything new, right? It's just 2 problems in one. 3 problems in one, I guess, technically. A lot more steps. So they're about to get a little bit more advanced each step. A couple more. 23. It is. It's a little bit nastier. Okay. Still not as bad as it's gonna be. Really? No, this is the thing is, guys, math isn't fun when you're doing easy problems because then you don't get a warm and fuzzy. But this is like when you start to get like, oh, that felt good to get that right. Okay, so we're gonna take this off to the side. I recommend parentheses, 2x plus 1 over x minus 1. I like to kind of spread mine out so I can show my work. X minus 1 over x minus 3. So you'd say, okay, I'm just focusing on the top and getting the top right, being so very careful. So now you'd say, I need a common denominator to combine this into one fraction. So I'm going to times by x minus 3 and x minus 3. Then right here, I'm going to multiply by x minus 1 and x minus 1. Now you're keeping your work very pretty. Remember at this point, now we're focusing on the numerator, right? See how there's so many steps you can get lost in what you're doing. You've got to be really careful. So now let's focus. We have 2x squared. We have a minus 6x plus 1x. That's minus 5x. And we have minus 3. Now it's a subtraction problem, so very important to put parentheses. x squared minus x minus x. That's minus 2x. Then we have a plus 1. Then remember, at this point, I personally take the negative and then distribute it through and write it underneath this section. So that's negative x squared plus 2x and then minus 1. And now I've taken care of this. Okay, so then from there, combine like terms, that's x squared minus 3x minus 4. That's your numerator. And that was all over x minus 1, the common denominator, x minus 1, and x minus 3. Okay, so I'm going to circle that. That was my top. That was only the top, right? All that, just to get the top done, to get a common denominator. Okay, so if we can factor that, I'm going to probably do that in a minute. So just, you can factor it right now, but I'm going to do that in a minute. Because isn't that a simplifying step? I just want to make sure that we're, okay. Moving on to the bottom. Well, there's no like terms to combine. That's not adding fractions. So what I would recommend, however, I really recommend it. If you get good at putting in your ones, it's going to help you from making algebra errors. Technically on bottom, we have x squared minus 3x minus 4 divided by 1. If we wanted to put it as a division problem, right? Okay, so now on top, we have x squared. Okay, sorry. I'm going to scroll down and write it down here. So on top, I have this. X squared minus 3x minus 4 divided by x minus 3x minus 1. And then that was divided by, divided by x squared minus 3x minus 4 over 1. So you guys see how if you save that factoring step for the last step, it might save you some extra work. But it wouldn't have been wrong. Okay, so now we flip and multiply. So I'm going to times by 1, and then x squared minus 3x minus 4. Now from here I would factor, but in this case we can see these are going to factor to be the same thing, which will divide out. So then this divides out with this. So my final answer is 1 over x minus 3 and x minus 1. There is literally 4 problems out of the 20. That's a lot. 4 out of the 20 are complex fraction ones. Yes. 4 out of the 20 problems are complex fraction ones. Questions? Still not to the advancedness level we need to be at quite yet. Here we go. Now, last hour, wanted to try this one by themselves. Alok actually got it right. Do you want to try by yourself, or do you want to just go through it so that we're quick on time? Okay, try by yourself, and hopefully we won't then go through it together. But let's all... What I would do, guys, if I was you, is I would get the top and then check it off with me, and then get the bottom and check it off with me so that you don't get to the end and have the wrong answer, you know? Okay? Because I do remember what the top becomes. Okay, ready, go. Be so careful getting those common denominators and combining like terms. You can do it. Right, it's just got to be so careful. Exactly. If you're having a problem getting to the top being this and the bottom being this, you're just having a hard time adding and subtracting. You know what I mean? So make sure If you're having a hard time with that, you need to get some one-on-one help. Or just retry it. It's easy to make one little error. Because then after that, the flip and multiply part's pretty easy, right? Okay, so I'm going to move on to the next example. So if you're not done quite yet, sorry. Okay. You can write down well, you have the answer, I guess, because you have this side. But I would love to go over this slowly with you if you need me to give you some one-on-one attention. Hey, everybody look. Back up here. This is going to be where you need to really focus in so we can fix some algebra misconceptions. So first of all, just a reminder, if you have a negative exponent, you can rewrite it as a positive exponent, as long as you remember how to do it. So just a reminder, if you have a negative exponent, you can take your entire base and you can flip it over a fraction, and that would make it a positive exponent. So this is 1 over x squared. They're equivalent. This and this are equal. Does everybody understand that? So what would I rewrite this as? What's an equal truth statement? 2x cubed, right? Everybody, you just flip it. Okay, now right here, this is x squared, y to the negative, x to the negative 2, y to the negative 3 over z to the negative 1. What's a truth statement? Z to the first over x squared, y cubed, right, everybody? So now let's look at this example. Now this is 32. Now there is a huge difference between this problem and this one. So everybody look at this with me. This one has all multiplication. This one, however, has addition and subtraction signs. These are going to work quite differently. So if you have just multiplication, you can start flipping over this one fraction. Now remember, this 2 is not connected to x to the negative 2. That's 2 to the positive 1. 2 will stay in place. Does everybody see? Yeah. So x squared can just flip right over, y cubed can come right up, and z to the 5th can come right up. Now that can only work because there's multiplication. If you have addition and subtraction signs, you can't take this and flip it down here. You can't flip over addition and subtraction signs. Did you all hear that? Okay, so how do we do it? Well, this is how. We do need to write them as positive exponents, but they can only flip over themselves. So let's just focus on that pink section. How would I rewrite that? 2 over x. Some of you are about to put the 2 on bottom. Ooh, don't do it. Don't put the 2 on bottom. Do you guys see what I'm saying? Okay, now there's still a plus sign, isn't there? How can I rewrite this section? 2 over y. Everybody good? All I've done is rewrite this, haven't I? Yeah. Then we have a divide sign. Now let's rewrite this section. X over y. Minus sign. Y over x. And now do you see how you've now just written a complex fraction? It just took a second to get there. Now you have to simplify it. So I'm going to quickly simplify this one. Now watch, if you're really advanced, this actually will simplify really quickly. So watch. You've got to be like really good at algebra to simplify this pretty quick. So watch, I'm actually going to kind of skip steps to this one. I'm just going to jump right here. Okay, common denominator. When I times by y and y. X and x. So now you combine the numerator. My numerator is 2y plus 2x over xy. Okay, great. Let's move to this bottom. We times by x times by x. Times by y, right? So this just became x squared minus y squared all over xy. Dividing fractions easy as pie. Flip the second fraction, multiply. So on top would be xy. On bottom would be x squared minus y squared, right? Next step is the factor. So let's focus here. Factor that. What do we pull out? To the left is y plus x. xy is already factored. xy is already factored. What does 2 perfect squares factor to be? X plus y and x minus y. We're not asked to restrict, so we can start dividing out exact factors. X and y divide out. X and y. X plus y is what I meant to say. So left on top was the 2. And then an x minus y. So pretty quick, right? That one was pretty quick. Okay, this is my last example of the entire day. You need to see one more with negative exponents. Here we go. Okay, let's see how we would rewrite this. That's the hard part, is rewriting it correctly. Remember, because there's addition and subtraction, you can't just flip that down here. Okay, so this is 1 over a cubed plus 8 over b cubed, then divided by 1 over a squared minus 4 over b squared. Now I'm going to just finish this bad boy quickly. So watch. B squared, b squared. A squared. True? This one was b cubed. A cubed cubed. Okay. All right, so now on top here I have b cubed plus 8a cubed, right? And that's all over b cubed a cubed. Divided by, right here I have b squared minus 4a squared. True? All over b squared a squared. Now I'm going to flip and multiply, so on top I'm going to have a b squared and an a squared. Then on bottom I'm going to have a b squared minus 4a squared. So major factoring is going to happen at this point. How do you factor this portion? Okay, actually I'm going to give myself, I don't want to have to scroll where I can't see it, so I'm going to rewrite it over here. It's two perfect cubes, everyone. Okay, so let's keep going. Cube root, cube root. Do you agree? So we have a b and a 2a. Front times the front, front times the back, back times the back. The original sign drops down, opposite plus. That was just for that, right? Then we still have b cubed, a cubed. Now this is still b squared, a squared, right? Then what is this factor to be? Two perfect squares, b and 2a, true? b plus 2a, b minus 2a. Okay, let's start dividing out exact factors. b plus 2a, b plus 2a. B squared and a squared, b cubed and a. So let's just do the b's separately. If there's two b's on top and three on bottom, won't there only be one b on bottom? And one a on bottom? And then anything else to divide it out? So on top we have b squared minus 2ab's plus 4a squared. See, this wasn't an advanced problem. I'm not going to try to pretend it wasn't. Then left on top was a bottom who was a b and an a b minus 2a. All right, you can do hard things. Make sure you're picking the hard ones. So in this section, I would do every odd because I would want to practice. So on Tudor Street continued, we talked about this. That would be 9 through 37. I would do every single odd, but that's just me. I'd pick the hard looking ones. The more you practice, the better you're going to do on the exam. Okay, that's the end of the lesson for today. That's the extent.